Welcome back to CS Connect series. In this video, we are going to discuss about few topics that were added to the set theory concept in some latest discrete mathematics books. We will be discussing about multisets and fuzzy sets and also a concept called Jaccard Similarity. In artificial intelligence, we will need fuzzy logic. So for that, we obviously need the concept called fuzzy sets. Set is not an ordered collection, it is unordered. As well as we said, the elements will not be repeated. Even if they are repeated, they are counted only as one element. Multiset comes into existence when we have the same element multiple times. Regarding Jaccard similarity, we will be using them in some latest kind of algorithms. Similar to machine learning algorithms, we will be using them. So this video will just introduce you to all these three concepts. You are just going to learn what are multisets, what are fuzzy sets, and what is Jaccard similarity. Apart from that, this will not carry too much of detail. We are just going to see very basic details and the fundamental operations that can happen in these sets. Let's start with multiset concept. What are actually multisets? Sometimes an element occurs a number of times in an unordered collection. Usually in set, we don't count the repeated element. But here, since the concept is multiset, we are considering the number of times that particular element is occurring. Let's take a multiset. It is actually called as multiple membership set. It means one member is occurring multiple times. It's an unordered collection of elements where an element can occur as a member more than once. In a set, an element either belongs to a set or it does not. We will say one belongs to A or one does not belong to A. That is with respect to set. In a multiset, each element is listed the number of times it occurs. If we say we have a element called A, then we should represent whether it is occurring one time, two time or three time. The multiset denoted by A, 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 B contains the element A thrice. So there are three counts of A and the element B twice. There are two counts for B. So A is occurring three times and B is occurring two times. What is the multiset notation? There is an alternate notation for multisets. Usually when we go for set representation, we don't consider the repetitive element. So in order to specify that this is a multiset, we go with this particular notation. We write the element along with the number of times it is occurring. So the order doesn't matter. We know it's an unordered collection. So when we say 3 into A, we can understand A has occurred 3 times. When we say 2 into B, we can understand B is occurring 2 times. So this is the general multiset notation we can take. M1 into A1, M2 into A2, MR into AR. So what is this M1 into A1? Element A1 occurs M1 times. And here the last one will be element AR occurs MR times. So with every element, the number of occurrence is also mentioned. Now what are these M1, M2 and MR called? Mi, otherwise expanded as M1, M2 and MR, are called the multiplicities of the elements. So what are the elements here? In general, we can represent it as AI, but here in this particular format, we have A1 element, A2 element and AR element. Elements not in a multiset are assigned 0 as their multiplicity in this set when set operations take place, and ultimately the multiplicity of a particular element becomes 0. At that time, it will be useful to assign 0. The cardinality of a multiset is defined to be the sum of the multiplicities of its elements. So let's take 3A and 2B set. What is the cardinality? This is given by 3 plus 2, which is equal to 5. So just count 1, 2, 3, 4, 5. There are 5 elements. So how can we write it in general? M1 plus M2 plus up to MR. This will be the cardinality of multiset. We have to just sum up the multiplicities of the elements present inside the set. Now we will look upon the multiset operations. Let P and Q be multisets. So what is 4 into A? There are 4 number of A's. Then we have 1 B and 3 C's. This is just to give a depiction of what is inside the set to give a better clarity. What about Q? We have 3 A's, 4 number of B's and 2 number of D's. C is absent in Q and D is absent in P. Let's start with union operation. What is union? The multiplicity of an element is the maximum of its multiplicities in P and Q. So when you take union, what we will do is we will pick elements either from P or from Q or from both. This is with respect to set. But when it is multi-set, we know there are 4 number of A's and 3 number of A's here. Considering them to be individual element, in union you have to pick all the 4 A's together. So for this A and this A you will have one A. For second A and second A you will have another A. For third A and third A you will have another A. But here you have another A remaining. So this will also be taken in case of union. So which count is actually taken here? The maximum of its multiplicities we can say. So here there are 4A and here there are 3A. Which is maximum? 4 is maximum. So for union purpose we are picking the maximum of its multiplicities. P union Q is equal to maximum of 4, 3 with respect to A, 1, 4 with respect to B, 3, 0 because C is absent in Q. So we have multiplicity to be 0. Now you can understand why we are assigning 0. Since C is absent in Q, we have the count of 0 into C with respect to Q. So we will have 3, 0. What about D element? Here D is absent, so we can take it as 0 into D and this is 0, 2. So 4, 3, 1, 4, 3, 0, 0, 2. First multiplicity is from P, second multiplicity is from Q. Now what is the answer? Maximum of 4, 3 will be 4 for A. Maximum of 1 and 4 will be 4 for B. Maximum of 3 and 0 will be 3 for C. Maximum of 0 and 2 will be 2 for D. So we are picking only the maximum of the multiplicities. So what is the union set? It is 4A, 4B, 3C and 2D. So just take 4A, 4B, 3C and 2D. This will be the union operation result. What about intersection? When we say something is maximum in union, definitely you have to pick the minimum from intersection. How many common A's do you have in both the sets? We have 3 common A's. So for intersection purpose, you have to pick 3 A's only. So here the count is 4, here the count is 3. Which count are you giving importance here? To the minimum count. The multiplicity of an element is the minimum of its multiplicities in P and Q. So P intersection Q will be minimum of 4 and 3 for A, minimum of 1 and 4 for B, minimum of 3 and 0 for C and minimum of 0 and 2 for D. Since C is present only in P and D is present only in Q, definitely C and D will not be a part of intersection operation. So for that only we are using the 0. Minimum of 4 and 3 will give 3 for A. Minimum of 1 and 4 will give 1 for B. Minimum of 3 and 0 will give 0 for C, which says C will not be present in the result. Minimum of 0 and 2 will give 0 for D, which will say that D is also not present in the result. So 3A and 1B. So now we have 3 A's here. What about P? It has only 1 B. But here there are 4 B's. So how many B's are in common? Only 1 B is in common. So we are taking it for the intersection. This will be the intersection result of P and Q multisets. We are again sticking to the same example. This time we are going to see difference operation. Multiplicity of an element is the multiplicity of the element in P less its multiplicity in Q. Let's take 4 A's in P and 3 A's in Q. Consider them to be individual elements. What does difference operation do? It should be present in the first set but not in the second set. How many A's are present in the first set? 4 A's are present. How many are present in second set? 3 A's are present. From this A is present in both, so we are ruling out. This A is present in both, we are ruling out. This A is present in both, we are ruling out. Now this A is present only in the first set and not in the second set, so we can pick this A for the difference result. What is happening between the number of A's? You are actually finding the difference between their multiplicities. So this is 4, this is 3. 4 minus 3 will give you 1, which is this 1A. If the difference is negative, the multiplicity is 0. Why do we say so? For P minus Q, this is fine. What about Q minus P? You will have 3 minus 4. All the 3 A's will go with these 3 A's in the P and only 1 A will remain in this particular P. Regarding the difference operation, only the first set should have and the second set should not have. But if the second set is going to have additional elements, you don't care about it. So this negative difference should be considered as zero multiplicity in terms of difference. That is why they have given this particular point. Let's take P difference Q. So let's find the difference initially. For A, we have 4 minus 3. For B, we have 1 minus 4. Take it in the same order, 1 minus 4, because it is P minus Q. What about C? We have 3 minus 0. What about D? We have 0 minus 2. Now the value here is 1, here it is minus 3, here it is 3 and here it is minus 2. Did we get negative numbers? Yes, we got negative difference here. In order to choose 0 instead of negative number, you can give the maximum function to pick the result. 4 minus 3 will give you 1. So 1 comma 0, which is maximum? 1 is maximum. So 1 will be taken. What about minus 3 comma 0, which will be maximum? 0 will be maximum. So in this scale, you have 0, 1, 2, 3. This is minus 1, minus 2, minus 3. So whenever you have negative numbers, 0 will be picked automatically when you use maximum function. And whenever you have positive numbers, automatically that particular number will be picked as the maximum number. This is the use of presenting maximum function in this difference operation. So you are presenting maximum function to pick 0 whenever you have negative number and to pick the positive number if the difference is positive. So 4 minus 3 comma 0, this is 1 comma 0, which will give you 1 into A. Then this is minus 3 comma 0, so which will give you 0 into B. Then this is 3 comma 0, which will give 3 into C. And this is minus 2 comma 0, which will give 0 into D. So remove the 0 occurrence here and then place only the positive digits. 1 into A, 3 into C will be the difference result of P and Q. This is for P difference Q. Now let's find for Q minus P. So what will happen? Maximum of 3 minus 4 comma 0 for A, then maximum of 4 minus 1 comma 0 into B, then maximum of 0 minus 3 comma 0 for C, then maximum of 2 minus 0 comma 0 into D. So this will be giving maximum of minus 1 comma 0 will be 0. So this is 0 into A. Then 3 comma 0 it will be 3. So 3 into B. Minus 3 comma 0. So it is 0 into C. Then 2 comma 0 we will have 2 into D. So Q minus P will have 3 into B and 2 into D as the answer. We have one more operation called sum. The multiplicity of an element is the sum of multiplicities in P and Q. When they have told about less its multiplicity, the difference, here we have another operation for sum. So this is denoted by P plus Q. How will we find it? We have to just add both the multiplicities. 4 plus 3 for A, 1 plus 4 for B, 3 plus 0 for C, and 0 plus 2 for D. What will be the answer? 4 plus 3 is 7 times A, 1 plus 4 is 5 times B, 3 plus 0 is 3 times C, 0 plus 2 is 2 times D. This is the sum operation. So how are we going to handle the multiplicities matters the most with regard to multiset operations. Now we are moving to the next concept, Jaccard similarity. This measures the similarity between two sets of data to see which members are shared and distinct. The Jaccard similarity formula, J of A comma B of the finite sets A and B. So this is with respect to sets and not multisets. It is given by A intersection B. What is this symbol? You have to take only the count of A intersection B divided by the count of A union B. So when you have A intersection B as 1, 2, 3, just take only the cardinality 3 to be this particular symbol's notation. Only the element will be counted with J of null comma null is equal to 1. Null intersection null will give you 1 and null union null will also give you 1. 1 divided by 1 will give you 1 somehow. So J of null comma null, that is empty set comma empty set, will be equal to 1 only. We have another term called Jaccard distance, that is denoted by dj of A comma B. The distance between A and B equals 1 minus the Jaccard similarity. Jaccard similarity is given by J of A comma B. So this will be 1 minus the Jaccard similarity. So if you want to calculate distance, you should definitely calculate Jaccard similarity. So we are not going to get into deep concepts where, why, how it is going to be used. We are just going to see sample problems to find Jaccard similarity and Jaccard distance. Find Jaccard similarity and Jaccard distance for these pairs of sets. Usually we should write this as D and subscript J. Let's take the problem. A is equal to 1, 3, 5. B is equal to 2, 4, 6. So what is A intersection B? We don't have any common elements between these two sets. So we can represent this by null set, which will give a cardinality of 0. So there are 0 elements in common. What about union? 1, 2, 3, 4, 5, 6. There are actually 6 elements in union. So we have A union B count as 6 here. What is the Jaccard similarity? 0 divided by 6, which is equal to 0. What about Jaccard distance? 1 minus Jaccard similarity. So this value will be substituted here. Jaccard distance will be equal to 1. This is one example. Let's go for the other example. A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, 6. Now we have to find intersecting elements. We have 3, 4 as intersecting elements, so the count will be 2. What about union? 1, 2, 3, 4, 5, 6. So again 6 will be the answer. So let me write the set here for clarity so that you can count the elements. What about Jaccard similarity? It is 2 divided by 6. Jaccard similarity formula will be intersection divided by union. And the Jaccard distance will be 1 minus Jaccard similarity. So 2 divided by 6 will be 1 divided by 3. What about Jaccard distance? 1 minus Jaccard similarity. So this will be 1 minus 1 by 3, which is equal to 3 minus 1 by 3, which is equal to 2 by 3. So distance will be 2 by 3. So this is how we will be calculating Jaccard similarity and Jaccard distance with respect to two sets. Next we are moving on to fuzzy sets. We need to understand fuzzy sets concept in order to dive deeply into artificial intelligence kinds of topics. So we'll get a basic understanding in this video. We are not going to go so deep and all. We saw the concept of multiset stating that an element can occur multiple times and the number of times is represented as multiplicity. So we have also seen the operations regarding those sets. Now we will look upon fuzzy sets. Each element in the universal set has a degree of membership, which is a real number between 0 and 1. Including 0 and 1 in a fuzzy set, yes. If you take a normal set, you have two options. The element is either present in the set or absent in the set. In computer representation video, for this particular set representation I am telling you, in the previous video, we saw that when an element is present, we represent it by 1. When the element is absent in a set, we represent it by 0. It is not present and absent, we can say it belongs to and does not belong to. This is what we did even in membership tables with respect to sets. So here, it does not stop with 0 and 1, but they say it has some degree of membership, which is a real number between 0 and 1, where 0 and 1 are also included. The fuzzy set S is denoted by listing the elements with their degrees of membership. Elements with 0 degree of membership are not listed. Let's take a set F which contains the famous people. So we are given a value that is called the degree of membership along with the set element. So if we take 0.6 and A, this will be the degree of membership and this will be the set element. So similarly we have 1, 2, 3, 4, 5 set elements along with the degrees of membership. So why are they in points? Because it should lie between 0 and 1. A has a 0.6 degree of membership in F. This is how we will be taking the meaning. B has a 0.9 degree of membership in F. C has a 0.4 degree of membership in F. D has a 0.1 degree of membership in F. E has a 0.5 degree of membership in F. Now what is this F actually? It is the set of famous people. The more degree of membership you have, you can say that person is more famous. So we can conclude B is the most famous among all those other people. So we can say it as set element, but here they are referring it to famous people. So instead of having some names, I have picked up alphabets. So let's take person A, person B, person C, person D and person E. This person B is the most famous because it is having the highest degree of membership. Then who is the least famous here? D will be the least famous because it has the lowest degree of membership. So just take a scale between 0 and 1. You have 0.1, 0.4, 0.5, 0.6 and 0.9. This is D, this is C, this is E, this is A and this is B. Now which is close to 1? So B is the most famous. Which is close to 0? D is the least famous. That's what they have mentioned here. Fuzzy sets are used in artificial intelligence. Now let's move on to the fuzzy set operations. Let's start with the complement operation. Let's take the same set of famous people with the same degree of membership. We know the set F is famous people. Then what will be the complement? It is the set of people who are not famous and it is mentioned by F dash. In multiset, while performing operations, we actually worked with the multiplicities number. In fuzzy sets, we are going to work with the degree of membership. The degree of the membership of an element in F dash is equal to 1 minus the degree of membership of this element in F. So you have to subtract these degrees from 1 in order to get the complement value of this particular set. So let's take f dash is equal to 1 minus 0.6, 1 minus 0.9, 1 minus 0.4, 1 minus 0.1, 1 minus 0.5. Now the value will be 1 minus 0.6 will give you 0.4, 1 minus 0.9 will give you 0.1, 1 minus 0.4 will give you 0.6, 1 minus 0.1 will give you 0.9, 1 minus 0.5 will give you 0.5. Now just take a scale of 0 and 1. This is for f dash. We have 0.1, 0.4, 0.5, 0.6, then 0.9. Here 0.1 is for B and 0.9 is for D. 4 will be A, 5 will be E, 6 will be C. In F, what did we have? We had 0.1 in D and 0.9 in B. So this is for famous people. We had the most famous person as person B. Here this is who are not famous. In this list, who is having the least value? B is having the least value. In the not famous list, who is actually scoring more? This D person is scoring more. Now we'll move on to the next set of operation. Let's take two sets of people because we are going to go for union and intersection. Fuzzy set of people who are famous will be taken as set F and fuzzy set of people who are rich will be taken as set R. Now let's get into union operation. What is union? Fuzzy set of people who are famous or rich, we can say. How do we actually go with the degree of membership? In multiset we used maximum function. Similarly, in degrees of membership also we will use maximum function. Degree of membership of an element in union operation will be maximum of the degrees of membership of this element in F and in R. We have to pick 0.6, 0.4 for A under maximum function, 0.9 and 0.8 under maximum function for B, 0.4 and 0.2 for C, 0.1, 0.9 for D, 0.5, 0.7 for E. We have to pick the maximum. So which is the maximum? 0.6 is maximum, 0.9 is maximum, 0.4 is maximum, 0.9 is maximum, 0.7 is maximum. So we will have F union R is equal to 0.6 for A, 0.9 for B, 0.4 for C, 0.9 for D, 0.7 for E. This will be the union operation result along with the degree of membership. Now we will move on to the intersection operation. Whenever we have maximum function in union, what should be the case? We will have minimum function in intersection. What is the intersection concept here? Fuzzy set of people who are famous as well as rich. So this can be taken as F intersection R. So this is or rich and this is and rich. Degree of membership of an element in intersection operation will be minimum of the degrees of membership of this element in F and in R. So again we have to pick the same set of degrees from both the sets and pick their minimum. So what is the minimum of 0.6, 0.4? It is 0.4 for A. The minimum of 0.9, 0.8 will be 0.8 for B. The minimum of 0.4, 0.2 will be 0.2 for C. The minimum of 0.1, 0.9 will be 0.1 for D. The minimum of 0.5, 0.7 will be 0.5 for E. So we have 0.4A, 0.8B, 0.2C, 0.1D, 0.5E. This will be the intersection result. We learnt about multiset and their operations. So under operation we learnt how to find the cardinality by adding up the multiplicities of all the elements. Then we learnt about union, intersection, difference and sum also. Regarding fuzzy sets, we learnt about three operations to find the complement, union and intersection. Along with that, we also learned about Jaccard similarity and Jaccard distance. This is just a basic introduction video to all these concepts. That's why I gave problems along with the explanation for all the topics. With this, we are completing this video. I'll meet you in the next video. Thank you, viewers.